Hey folks, this is the NetDevOps tutorial. It is going to be really cool. So next to me are your tutorial leaders. It's going to be Bronwyn Lewis of Packet Clearinghouse and Matt Peterson of Cumulus Networks and Burning Man, as he has pointed out before. And they're going to go on and talk about network automation and how you can do really cool things on your network with Ansible. So I'm going to go ahead and turn it over to you guys. Thanks.
Thank you. As soon as I get the microphone here. Test 1, 2. Well, good morning, everyone, and hopefully folks have recovered from the Torix social last night. So for this morning's tutorial, we wanted to kind of frame some of the assumptions for the audience and what we'd like to get out of this for everyone that's sitting out there, what's expected. I've got a picture of a fiber post sign, and the analogy there is that if you're taught fiber splicing, for example, that doesn't necessarily mean that you could build a complete fiber to the home network. You still have to solve billing and routing and logistical problems. And DevOps and automation is very similar. So if you already know Ansible and you're already familiar with the kind of DevOps concepts, this is probably not the tutorial for you. But if you haven't heard of either of those, it will probably be quite interesting. We're going to focus on some high-level DevOps concepts, what those are and how you can apply those to your organization. And then we'll be utilizing a sample tool, in this case Ansible, to generate some config files that you could use to deploy to your switches or routers. Again, this is just an introduction to those concepts. We hope to plan a series of these talks if the PC will have us back, and we will continue additional tutorials in the future. So for the agenda, it's pretty straightforward. We're going to talk about some of the dependencies, the technical dependencies. So for folks that haven't prepared ahead of time, they can download the various software and VM images and get that up and going so they can follow along by the time we do the hands-on demonstrations. So we'll cover some DevOps concepts and terminology. We'll dive into some of the specific terminology utilized within Ansible, a tool that's very popular in DevOps organizations. We'll actually walk through that tool and create some configuration files, and then leave the audience with some homework, some next steps on how they can apply that to their network or their infrastructure.
So
go ahead.
We're going to start with the prerequisites. You should, if you have not yet already, go to this URL and you want to clone this repo. If you don't have any experience with Git and you don't know what cloning is, that's fine. You can also download a zip copy of the file from the same page. It'll be on the lower right-hand side. And you need these files at bare minimum to be able to follow along with the instructional and hands-on portion of the tutorial. If you've already grabbed this last night, because we did send out an email prompting people to do this, then you might want to grab a current copy this morning of the files. But if you set up your VM last night, don't worry, just grab the new files. You don't need to do any special new setup. The really important thing about this is for the tutorial, hands-on section of this, you do not need to be a programmer. You do not need to have any programming experience. You just need to be able to do basic navigation, make directories, make and edit files on the command line. So you need the basic familiarity with the command line, and you need to be able to use a text editor on the command line. I prefer to use Vim, but it's a little advanced, so if you don't have a lot of experience with that, Nano is perfectly acceptable. So for the environment, these are just some really quick notes. You want to see the Git repo for the details on this, but Ansible is officially supported on Linux and the Mac. It's not officially supported on Windows, but some people have kind of hacked together a solution. Proceed with caution there. There's details on the Git repo for that.
So one thing that's important to note with the instructions is that we highly suggest people do this work in a contained environment. So VirtualBox, the logo in the middle there, is a GUI interface for managing VMs under Windows, OS X, or even Linux. And it's a nice environment for creating VMs, modifying them, resizing, that sort of thing. And we think it's a really good way to demonstrate Ansible because, again, it's in a contained environment. So it won't have any impact on the libraries or modules that may be installed on your system by default. For Ansible itself, its prerequisite is Python. So it needs the Python package installed. And then Ansible has a number of Python dependencies. And an additional optional module that we'll be demonstrating today is the NetAdder module. So this is a Python module that does IP calculations. This is not typically a requirement for Ansible to be installed with that module, so it's an add-on or an extra module. And again, on those Git instructions, we've provided guidelines on how to do this with VirtualBox and an Ubuntu image. But if you're using something like CentOS or FreeBSD, even OS X on your laptop, the package names might be slightly different. So what if you have a laptop and you haven't had enough time to download the prerequisites here? You can still follow along in the demonstrations where you can write out text files and make the directory structure, and then use this infrastructure later when you want to download those dependencies, essentially the Python modules and the Ansible runtime. So you can still follow along if you don't have all those prerequisites, and at least type up a sample or something to utilize later in the day.
So you're probably wondering who we are. My name's Bronwyn. I'm an engineer at Packet Clearinghouse, which is a 501c3 nonprofit. I like to say we do internet infrastructure, but we do DNS Anycast, and we do operational support for some root server operators around the world. We have physical locations in over 100 different places, various countries, always at internet exchange points. And we do a lot of work with internet exchange points to get them established and help them donate equipment, stuff like that. I do a lot of different things at Packet Clearinghouse. I got started just doing provisioning, but I've kind of expanded into general network systems and now automation as a result of getting into Ansible. And I have a pretty diverse background that's not necessarily on this side of things, but I've always been a little nerdy and love taking things apart and trying to put them back together, sometimes successfully, sometimes not. And the big thing is that I got into automation because I was tired of repetitive work. I didn't want to do the same thing over and over again and make the same mistakes over and over again, especially because I was provisioning hardware and I had a lot of typos, or if I copy and pasted the wrong piece into the config, I had to start over from scratch, and it got really frustrating.
And myself, I'm Matt Peterson. I work at a company called Cumulus Networks. I work in the office of the CTO, so that essentially means that I write code, or I'm out in the field, or pretty much any gaps in the dam I help fill as best as I can. I also run an internet exchange called SF Mix, and my background is more on the systems side. For most of the organizations I've been at, I've typically been part of the system administration team, sometimes founding those teams. And for most of those organizations, I just became kind of the default network guy. So getting IP space and bringing up BGP and that sort of thing. So I've kind of fallen in that role a number of times. And at Cumulus, what's interesting is our product is essentially deployed in a lot of greenfield applications. And in those environments, automation is pretty much mandated because they're going forward to try to scale their networks. And automation is really a key tenet of that. We're obviously not speaking on behalf of any particular experience from our companies, and neither of us work for Ansible Inc., the company that writes the product. So why listen to us? I think that looking at data is very interesting for tutorials, talks, and panels. Nick Hillard from INEX, the Internet Exchange in Dublin, basically started this trend of presenting data back to engineers a couple years ago, and I found that really fascinating. And he focused on data around peering and internet exchanges. And this chart is going to focus on data around talks or discussions on automation versus IPv6. And if you look at IPv6, we've had about 15 years of discussions. That's as far back as I went on the NANOG presentation archive. And the trend that's interesting about IPv6, if you look at the type of content that gets presented, it essentially starts out with technical fundamentals. The second phase is usually kind of real-world feedback or experience that folks or operators have seen in the field. The third phase is typically best practices. A great example of this with V6 is, well, what sort of subnet do you use for a point-to-point interface? There's been a lot of debate about that over the years. So again, that gets refined as a best practice. And then you basically end on this kind of continued evangelism portion. Of course, that's why I have the pictures of Martin Levy and Mike Lieber there, is that they did quite a bit of evangelism around V6. The other metric that's in this graph, that's the darker color, that's on automation topics. So things like tickle or expect. We had a discussion around NCG an open source configuration tool geared for networking. Of course, NetConf and Yang and more industry standard automation approaches have been presented. And if you layer that on with the uptick of V6, it's kind of interesting where 2009 was the peak of content around V6. And if you look at Jeff Houston's table of how many V6 prefixes are in the routing table, it seems to start going on upward slope after 2009. Now, this is obviously not a direct correlation. This is clearly not a scientific method. But it's an interesting data point to note that there's kind of this trend of initial kind of discovery, best practices and refinement, and then evangelism, and it takes off in the real world. So we're hoping that automation and the DevOps concepts become second nature to NANOG going forward. So let's talk about DevOps and kind of the splinter of NetDevOps. I promise this is not going to be as vague and architecture as SDN or NFV or all the other sort of hyped acronyms that you may be hearing out there. The way I look at this is that protocols mature and evolve, and so do practices and workflow. So we still need driving directions, but there's different approaches to driving, right? So if you're navigating in an area that has no cell coverage and maybe limited or no GPS coverage, well, a physical atlas is pretty useful, and they're still printed, they're still made. You note that atlas actually shows 2006 as when it's valid. So these are still published and still available. Well, what if you've got no cell coverage, but you got great GPS coverage? Well, then a Garmin or one of these navigation units work really well for that. And if you do have cell coverage and you have GPS coverage, well, then maybe you use your cell phone and you get the added benefit of live traffic and updates that push to that. Again, you're still navigating in all three approaches here, but it's different technology. Ultimately, networking is an industry that's in transition. And I deal a lot with this at my day job because we're obviously a newer network operating system that's available to the industry. And what's interesting here is that all these efforts, whether it's an orchestration framework like OpenStack, or it's an open network operating system, or it's some sort of infrastructure in between, ultimately what they're driving for is greater operational insight or responding to the business needs quicker. At this point in our industry, we're competing against cloud providers, and they'll be more than happy to take your customer's credit card and provision resources for them within minutes or hours or milliseconds, right? So they're very fast to respond, so we need to catch up to those. And when you look at networking today, it's a packaged appliance that you receive. They dictate the hardware, the software, the support, what modules you can plug in, what optics are supported. It's a real challenge to be able to innovate within that ecosystem today. So a lot of the reason for these new projects around orchestration or open network operating systems is really to free up operators to drive efficiency with automation. Automation solves real operational needs today. You can automate infrastructure and then swap out vendors in the future. And that's very powerful. When we look at compute and storage, they've already been liberated. There's no longer the old school approach of, okay, well, I buy my monitor cable and my SCSI hard drive and my C compiler and my training from one supplier. That company's gone, right? This is Sun Microsystems, SGI. That ship has sailed. Networking is going down the same path. Compute is a great example of this. Today, people can choose to buy Dell hardware. They may deploy CentOS on it and use MongoDB, and then Ruby as their scripting language. They get to pick and choose what's appropriate for their organization. So why should networking be any different? DevOps is about uniting people and process. It's shared responsibility. 15 years ago, when I started in the industry, we used to call these folks tools developers. These are men and women that knew M4, Make, CF Engine. They would fire up a bunch of parallel SSHs. Very, very powerful tools within your arsenal of getting work done. These were sysadmins that became programmers, or programmers that became focused on system administration. Computers are really good at mundane work, and it turns out that configuration is pretty boring. Network engineers, your value is bringing architecture, design, scaling, monitoring. It's not cutting and pasting from Notepad into a CLI. Right? When you're provisioning new equipment, or you're replacing equipment, or you're doing expansion, configuration management can dictate your organization's particular policies. So you may have a policy that says we're always going to use a particular type of spanning tree. We're always going to name our routers and switches based on an airport code. We're always going to have interface descriptions include a customer or a circuit ID. Again, you have these policies within your organization, and configuration management can enforce those. Another point to note is that when you ask a typical network engineer to describe his or her network, what's interesting is they typically go to a whiteboard or they provide you a diagram. It turns out those are really useful for humans to read, but not machines, right? So if you can describe your network in a machine and human readable format, that's incredibly powerful. When you look at the entire infrastructure as a whole, that's typically what your customers are buying. I've never had a customer that just pays for ICMP or Echo. They typically are paying for access to the network as a whole. They want to be able to run their applications. And so DevOps is around looking at that entire infrastructure. So the example I show on the slide there is that your networking team may be focused on monitoring physical components within their switches or routers or various network appliances. But it turns out that your customers only care about accessing that application. So if you can unite the monitoring between all these different parts of your organization, ultimately that's going to benefit your customers. And the final point here to make around DevOps is that by using configuration management and some of these DevOps approaches, you get a really convenient audit trail as a byproduct. And this is really useful for a lot of organizations that need to go through various compliance steps, whether you're using a certification like PCI to accept credit cards, or maybe you just need an audit for your leasing company to return hardware or line cards that you bought on a lease line a couple years ago. Again, that consistency is possible by adopting some of these DevOps approaches. Now, unfortunately, this is a tutorial around Ansible and a network engineering focused event. So we're not going to give you a sermon on what DevOps is. The great thing about DevOps is that there are thousands of thought leaders and folks that are really passionate about this, and they're only a tweet or a blog away. There's some great books that you can buy, some shows that are podcasts or are videos, and we mentioned some of those in the links there. I think the summary here is that there's some initial time investment into thinking around developing these DevOps approaches to your workflow in your organization. But it's really minimal financial commitment, and it's a significant payoff. If you look at all the large cloud companies that are already scaled to this size, they've been practicing these approaches for several years, in some cases over a decade. I want to close on DevOps is focused on empathy, respect, assistance. We all work for the same organization in many cases, so why should the network team be against the network architecture team, or why should the engineering team be against the operations team? Work together. So when I look at networking automation from the outside, from my systems background, it's pretty medieval. It's pretty arcane. The systems side of the house, computer infrastructure, whether that's Windows, Linux, BSD, pretty much any computer infrastructure you can think of, is pretty modern. And what's interesting is because those operating systems have been open essentially for the last 20 years, there's been significant innovation there. When I started in sysadmining and worked at a NOC and did on-call and all sorts of things, CF Engine was tried and true, and that was a very popular tool at the time. Now what's interesting is a lot of CF Engine folks got frustrated, and they made their own fork of a different approach, and that was Puppet. And then we had Chef, and then we had Ansible. And all these things get a little better each time, and they solve slightly different problems. But if we look at that innovation that's occurred on the networking side, it's pretty minimal. Again, what's happening there is that you have legacy networking vendors that are dictating, again, what operating system features are available. So they're going to dictate what software is there, what scripting languages are available. If you pick an open operating system, you of course have that flexibility, but that's only been around for a few years. So one of the things that's interesting here is that I like to summarize this as kind of the pigeonhole path, that the technologies that are vendor-driven or exclusive to networking, they tend to get rare adoption. Part of the challenge here is that a lot of the traditional or legacy network vendors, they consider their CLI essentially intellectual property. In fact, there's a very famous case right now going through the courts around that very CLI becoming IP. And what's interesting about CLIs is that they're really terrible to do automation or scripting against. The prompt will change, the output will be slightly different depending on what version you're running. They're pretty painful. And so in most cases, a lot of organizations have consumed automation through SNMP. And SNMP was never really geared in the real world to do the type of networking changes that are required. So while it may be great to pull interface stats, have you ever tried configuring a VLAN on a particular interface via SNMP? It's pretty painful. You have to get a bunch of data, correlate that, and then set a bunch of data. It's not easy to do.
So there's a lot of different options today on the compute side with these new automation tools that are kind of off the shelf at this point. And there's always the option that you could write your own also, right? These are all great tools on the systems side, but networking can be a little bit more challenging. The systems team at your organization is probably even using one of these tools today, or something that they've homegrown themselves. But these really aren't networking automation tools, even though there's some cool stuff being done. With newer equipment from Cisco and Juniper and others, they're starting to build APIs and modules and that sort of thing. But maybe your network doesn't have the newest and latest equipment. Maybe it's a mix of things. There's still a lot of new equipment out there too that just doesn't make it easy to use these. And writing your own, it's great in theory, but it requires a lot of resources. You have to have the time, you have to have the money, you have to have the people. You don't want to reinvent the wheel. And when using one of these, you can much more easily hire someone off the street who's used one of these at a previous organization, because it is open and out there and a lot of people are using it. So what's great about today's compute automation tools? The technical benefits are, it executes tasks in order for the most part. It operates the same every time. Again, for the most part, none of these things are perfect. And it usually only changes what it needs to. If it doesn't need to change something, then it doesn't touch it, which is ideal.
I think what's interesting here is that all these open source tools that have, again, had a lot of traction in the compute space and are being kind of jury-rigged or hacked, or now even officially supported for networking, is if you look at how they're approachable, there's significant community behind these resources. So not only can you go directly to the developer that writes these tools, such as Puppet Labs or even Chef or Ansible Inc., but you can go to third parties that have experience deploying that tool in a large fashion. And I think the challenge here is, if you look at traditional networking vendors, something like Tickle or Slack scripts, it's going to be a challenge to find someone essentially under 35 who's ever even touched those technologies. Again, because they're very focused on a particular network operating system, where these other tools have been really focused on compute, so they've worked in a bunch of environments.
So we're going to talk about a couple of key ideas with these automation tools on the compute side, and that kind of translate to the network side also. These modern automation tools, they have various layers of abstraction, and essentially they use a top-level set of instructions that some of them call a cookbook or a playbook, or it's some way to kind of bring all of the abstraction together in the end. So you're not actually typing raw Bash or Python or Ruby, but it's a higher level language where the syntax is usually specific to the tool. But it's a lot more human readable rather than machine readable. It has its pros and cons. Usually you don't have to repeat yourself. You write something once in one place and you can use it all over. But sometimes when things don't work right, it can be a little more challenging to debug.
Yeah, so these are typically called a DSL or a domain-specific language. So again, as Bronwyn mentions, this is a high-level language to extract some of the low-level tasks you're trying to do. So in this pseudocode example here, if we were to assume that my server 1 was an Ubuntu host, the abstraction will automatically know I need to use apt-get, because that's the program to manage packages within Ubuntu. And if my server 5 is Red Hat, it would know to use yum. And again, you didn't specify that in the actual pseudocode itself. The abstraction was very powerful enough to say, okay, let me detect the operating system first, and then I'll pick the appropriate tool.
So signaling, this is how the tools actually communicate with the local host, or where you're running the automation tool, and then the remote host that you're running this against. So the two different versions that you tend to see are there's an agent or there's agentless. And an agent requires known software to be installed, credentials already, usually opens up something like an SSL connection between the two pieces of software on the different devices and communicates that way. Agentless, there's fewer requirements. There's usually nothing special on the remote hardware. In an example that we're going to give shortly, you'll see that in that case it uses SSH to then push out information and it gets information back. So here's one example. I'm just using Puppet in this case because it was easy to find the icons. But there's lots of reasons why an agent can be really good and you want to use it. It can be tricky though when it comes to networking devices, since they haven't necessarily caught up with the compute side of things. You know, as we mentioned, it's starting to open up. There's starting to be APIs and SDKs and modules being written, but it's still slow progress in that regard. So in this case, you have the agent software installed on the remote host, the client on the right-hand side, and then you have the control host on the left-hand side, and that's where you have, you know, the Puppet master in this scenario. So you write out your information in the Puppet master, and it connects via SSL with the remote host, the client, and it communicates that way.
Yeah, I think one of the things to note here is that when we look at traditional or legacy NOS vendors, what's interesting is they're cherry picking which of these solutions that you can use. So one of the difference between an open networking vendor versus kind of a traditional closed vendor is that they'll dictate again that, well, you can use Puppet, but it's only this particular build on this particular platform with this particular version of Puppet. So that can be a real challenge in using configuration management with an agent-based solution, because you may be using a more modern version of that software or a completely different software item. So again, agent-based solutions can be challenging for a lot of network devices.
So here's an example of how Ansible works. There's the local host, which you have Python and Ansible installed on. And then on the remote host, ideally you have Python. It gets a little tricky there, but ideally you do want Python if you're going to communicate with it. And then you need the ability to have an SSH connection. So you make that SSH connection. Ansible bundles everything up into basically, you know, like a Python bundle, pushes it over, and it gets executed on the remote host, and it communicates back that, hey, everything worked out great. I'm going to clean myself up and come back like I was never there, which is pretty cool.
Yeah, there's some interesting properties of this agentless approach. You know, one of them is that the dependencies are a lot less on the remote host. And if you look at large deployments of Puppet and Chef and some of these other tools, there's quite a bit of infrastructure just to get up and going before you can consume those tools. So that's one of the reasons why Ansible has become popular, is because the prerequisites are quite minimal. The other thing is that they can take advantage of infrastructure that's already in place. So you may already have SSH configured a certain way to use two-factor auth or certain non-standard ports, that sort of thing. And again, Ansible can consume that standard that you've set up.
So the other cool thing about Ansible is it's very easy to run just locally. So you don't need to actually SSH out anywhere, and you can just run it locally and take advantage of the templating feature, and in this case, the IP address calculation, which we're going to be doing today. So why did we pick Ansible? Well, we touched on a lot of these key points. Not having to install an agent, it's a pretty big deal. We may not want to, and it may not even be an option for us on the networking side of things. It's also pretty low risk for us, since what we're learning today doesn't involve touching any actual devices. We can just run it locally, which is really great. It doesn't take a big investment, either in money or time. Ansible's free. A lot of these tools, including Puppet and Chef and all those, they have like an initial like free version, and you just pay for professional services. And that's really helpful. But for us, the big thing was time. We didn't have to invest a ton of time in trying to figure this out and get things up and running and going. And both of us found it pretty easy to learn. Matt has a lot more experience with other configuration management tools like Puppet and Chef and that sort of thing. And I actually don't have any experience with other tools. I just got into doing this because it was easy and I was tired of doing the same thing over and over again manually.
So let's start with some terminology that's focused around some of these DevOps concepts, but also Ansible specific. So hopefully your coffee has kicked in at this point. Any slide that has this little red Ansible icon, that's a version of their logo, that will be something that's specific to Ansible itself. So let's start off with YAML. YAML is a human-readable file format for describing data in a structured way. It's very similar to JSON. You have key value pairs, you have dictionaries, you have lists, arrays, that sort of thing. What's nice is that with YAML, you can actually do a little bit of a markdown format. So you can indicate that this is an integer or a string just in the way that it's encoded in the YAML file. So if you have any values that require colons, you would obviously have to quote those. But it's a pretty simple file format, and it's become very, I would say, hip to programming languages to consume this as a configuration file, or just kind of a basic structure versus, say, like an INI file or a CSV output, that sort of thing. Jinja 2 is a templating engine or a templating language within Python. So this allows you to take variable data in, enumerate through that data, and then compile out a resulting file. So this is extremely popular for people that are using Python for website development, where they're enumerating through data that's from being retrieved from a database or a form. One of the things that's really interesting about Jinja 2 is that you can actually do some conditionals and a little bit of programming within the template itself. And some templating languages see this as a benefit. Some actually remove that infrastructure. But we'll show you an example where it can be quite powerful to actually set a variable within the template itself, or do some conditionals, obviously, within the template based on that variable data. So host, so you note that it's got the Ansible icon there. This is an Ansible-specific concept here. So Ansible has a host file, and this is where you can group remote host, local host, all the hosts that you'll be talking to. Now, by default, it's going to assume that these hosts can resolve in DNS. If they can't, you can actually specify the IP address of the host. You can also specify variables that are specific to that host. So if we walk through the example there, we basically have a dev group and a prod group. In test switch 1, we're setting a management IP variable. The second IP address that's listed there, we don't have a host name assigned to that. For dev router 4, we assume that that resolves, and so forth. Ansible assumes that this is usually a system-wide file, but we're going to overwrite that and specify a local location for that file with a slightly different concept called an inventory. So playbooks are essentially the heart of Ansible. They bring all these elements together. So these basically specify all the different roles or tasks that you're going to perform and on which host or which group of hosts. Now there's some additional metadata that you can turn on and off here, things like gathering facts, which is coming up in the next slide here. But again, playbooks are, as Bronwyn mentioned, kind of that high-level abstraction of saying, okay, what is the recipe or what is the cookbook that I'm trying to accomplish here? So facts. These are metadata that can be used for conditionals. So as you can imagine, when you log into a server, there's a lot of metadata that might be useful. For example, all the interfaces that are configured on that server, what are the IP addresses for v4 and v6, how much RAM, hard drives, all this sorts, again, of metadata. And that metadata is exposed as variables within Ansible. So you can actually do conditionals or logic based around facts. And facts, again, can be discovered at runtime when it logs into a host and initially gathers that data. Facts can be statically set, or you don't have to gather facts at all. It's an optional component. But they are very powerful to use for conditionals. And now we have inventory. And you want to talk about that?
Yeah, I can talk about inventory. I love inventory. Inventory and roles are my two favorite things. And they're not something that you normally use in like just a very basic Ansible situation, but I found that it makes life much, much easier. So we'll actually be using them today. So the cool thing about inventory is it allows you to group together hosts and variables and make those variables accessible across roles if you want. We'll delve into that a little bit later because you can put variables in a bunch of different places. But the nice thing about this is if you do have that set of variables that you want accessible across, say, your routers, your switches, your servers, there's a place to put that. More importantly, with the hosts, you don't have to use the default host location when you're using an inventory. Instead, you create this file, which you can see in the example on the left-hand side there. There's a host file. You just put your information there, and it also makes it very portable in that respect. If you're using some sort of version control, like, say, Git, you can then have this host file checked in. You don't have to worry about it being your etc Ansible host file on your system, which is also a little tricky when you're on a Mac. And roles are really cool too, because these allow you to kind of break out those different things. Like, you could put tasks and variables and even templates all into your playbook, but it gets really cumbersome if you're trying to do anything that isn't super, super basic. So roles allow you to compartmentalize that instead. So you can group together the tasks and the templates and the variables for just your routers, or just your switches, or just your servers. And it really makes scaling and collaboration a lot easier. I personally love breaking things out into as many roles as possible because it's very easy to collapse roles down into each other. It's very hard to break them out though. So I usually will just work on everything as a separate role, and they'll be like, no, it makes more sense to kind of combine these later. And it's a lot easier to do that then, especially when you're collaborating with people.
Yeah, so in the case of SF Mix, we utilize Ansible to drive not only our website, but a lot of our infrastructure. So our route server, our forward and reverse DNS, a lot of that infrastructure. So we have a common group variable, a YAML file that structures all of our member data, like their MAC address and their email address and that sort of thing. But we have separate roles for the website, for the route server, for DNS. So when we have these hack weekends, we can have multiple people collaborating on different tasks that Ansible is going to perform, but they're not all editing or fighting for the same file or the same role.
Yeah, we avoid a lot of merge conflicts then, which is good. Okay, so now it's time to get your hands dirty. Hopefully you guys were able to set up the environment, and if not, as long as you have a command line and you can edit on the command line, you can still follow along, create these files, edit the files and the directories and everything, it'll be fine. But here's just a general outline first. So we're going to touch first on the inventory and the roles because they're structural in nature, and it really helps to have those set up first before we dive into everything else. Then we'll do the variables, followed by templates, the IP address filter, the tasks, the hosts, and finally the playbook, and we'll run the playbook at the end. We're going to do like a basic version of a config first, and then as long as we have time, we'll do some more advanced stuff. We'll revisit those files and continue building on them, which is really exciting. Okay, so here's the first example that we're going to show you. And don't worry about trying to follow along with this. I've already pre-written this little demo so that we can just switch to the command line, I can run it, and we can explain a couple of things here. Go on to Hello World here. You can see the different files. I'm actually going to remove this real quick.
Can everyone in the audience see the output? Is it big enough, the font and everything? Okay.
All right, cool. We tried to tweak that
Thank
in
you.
advance. Thanks. Okay, so now, and I'll explain all of this later.
Let's adapt.
Oh, thank you. It's too early. I'm going to make typos.
And then the other one. So the PC requests us to do a live interactive demo. So if you can imagine doing a demo on stage is pretty much guaranteed to fail. So
yeah.
We're hoping that that will not be our example today.
Okay, so let's go ahead and break this down a little bit. So we ran this play, and I'm just calling it Hello World. There's some tasks inside of it. You can see that the changed, and it says it's yellow right there. So when it's green, it says it ran, but nothing got changed. If it's yellow, it ran, and something changed. And if it's red, then there's a problem, and it failed, and probably nothing changed at all. So in this case, everything worked. We created these new files. Worked great. This task here just verified the compiled directory exists because I wanted to create an output directory that I could put all of my generated files into. And then this task here says generate hello, and I just created these files, and you can see these variables that got passed in there. And then there's a play recap at the end. It just says where it was run, which was localhost in this case, and says, okay, everything worked, everything got changed, and nothing failed or was unreachable. So now this output file their output directory got generated there, and if we look in there, there's 3 files. So we're just going to look at 1 or 2 of these. So that just says hello world. And that one says hello NANOG. So we're going to go back up here real quick, and I'll go into detail on all of this, but I just wanted to show you guys how this works.
The playbook first.
Hmm?
The playbook first.
Oh yeah, that's a good idea. We'll do the playbook first. So here's that playbook. And the playbook name is arbitrary. You can call it whatever you want to. The same with the inventory. I just called it that for clarity. So here's the playbook. We just said our play is going to be hello world. The hosts are going to be localhost. Connection will be local. We don't want to gather any facts because that doesn't matter to us. And we're just going to use the role hello.
Yeah, so as Bronwyn mentioned earlier, Ansible has some basically best practices of spreading out these multiple steps where you specify where hosts are located, what those variables are, the particular tasks that you want to perform. So they're kind of spread out. So again, the playbook is kind of the heart of Ansible execution, and then things are kind of broken out. So we'll go into a particular role that was defined. That's called the hello role. That's under the roles directory. It's called hello. And then This again follows kind of a standard Ansible approach of having tasks, templates, and variables that are specific to that role.
Okay, so in this case, we're just going to take a look. We're in the role now, hello, and we're going to look at the tasks main.yaml file. The reason that's called main.yaml is because when you're using roles, it defaults to just using the main.yaml. You can use a different YAML file, but then you have to specifically include it, and it gets a little more complicated. If in tasks and vars, you just use main.yaml every time, put all of your information in there, it automatically gets pulled in, which is great. So here's the tasks that were executed. So you can see the first one was we wanted to verify that compiled directory. And so we have, okay, we're going to do this file. The path is going to be this output in the home directory there for where we were working. And the state, we want to make sure it's a directory and not actually a file. The next task, generate hello, we're using a template. And you can see the template referenced here is hello.j2. And when I don't specify where this template's coming from, because you're in a role and it knows to look in the templates folder inside of the role. And I specify the destination is that output directory that I created up here. And then in this case, I just wanted to iterate through this item.number, which is one of the variables I have available, so that I could have it called hello-1, hello-2, or whatever variable information I had in there.
So one of the things to note here is that this is a YAML file or a compliant to YAML. So again, the playbooks, the tasks, variables are typically written in this file format. And what you see there are modules. So file, for example, and template, these are built-in modules that Ansible supports, and then they take these various directives. So file, for example, you could say, make sure this file exists, or it doesn't exist, or create this directory, or remove this directory. So there's different options and arguments for each of these files. Template is what's called the Jinja 2 templating language. So that, again, that's why you see the source file there is a .j2. We just name it that, again, to follow a well-known standard. And the with items is actually a loop, and Brahma will show you the variables that are sourced from that loop.
Okay, so now we're going to look at the variables file here. So you can see we had that with items up above where it said info, and it's because we were iterating through this info section here, and then we had multiple lines with different sets of variables. So we've got the name and the number in each set of variables, and that's what needed to be iterated through, both for the item.number, where we were renaming the text file, and also in the template, which is what we're going to look at next.
So you'll note this looks like a kind of a standard dictionary or an array, depending on language you're coming from, and again, a YAML file format.
Yeah, and there's a lot of different ways that you can format variables in Ansible. This is just one way we found that is pretty easy and bulletproof, because formatting variables in Ansible can get a little weird sometimes, and it's been many a headache for me in terms of trying to figure out, oh, well, how am I going to pass in this specific variable in this different format? So we wanted to go with something that was a little more accessible, which was this particular format. So now we're going to look at the template that we have here. So you can see it's just very basic. It just says hello and then the item name. So we're just passing in that item name when it iterates through there. So it ties those items together. It says, okay, hello-1.txt is the file that it's going to be. And since I'm doing that, I'm going to pass in the world name. So then it'll just say hello world.
So in the Jinja 2 template, you can pass in particular variables as a string, and that just gets passed in directly, so that we see the parentheses there. There's also conditionals that you can put within a Jinja 2 template, and we'll show that further on, where you can actually do some if-then statements or other conditionals within that template file.
Okay, so let's go ahead and go into the workspace. If you have the Git repo either downloaded via zip, or if you have it cloned. So in here, there's just a README right now, and there's a reference. Let's take a quick look at the README, because this is going to be useful for people. This just has some info in here. Essentially, this workspace is just meant so that you can follow along in this tutorial. There's some details on the Jinja 2 formatting. You don't need to worry about reading this right now. This is just for reference. There's a lot of different ways that you can include information. So there's statements, expressions for printing, comments. I just tried to create basically an essential little cheat sheet with really the core things we're going to try to show today and get you guys going with. See if you scroll down here. Yeah, so here's an example of doing an if and an elif and an else specific to NANOG. So it says if nanog.montreal, then poutine, elif nanog.san Antonio, okay, barbecue, else I'm not sure what to have. Here's an example of a loop, and we'll get into doing these later in the tutorial. But essentially, you can loop through the data and reproduce it inside of this template multiple times then. So you can print out, the city, the country, the date, the attendees number for all the past nanogs if you have that data set available and in that proper format. And then the IP address filter, there's lots of information here, and we can get to all of this later, but I just wanted to provide this reference to people so that they had it.
So one of the things to note here is that we're trying to slowly introduce these concepts because it's a lot to grasp. Writing templates in a particular language, executing particular roles, it's a lot to grasp there. Can we go back that file for a second?
Yep.
Towards the end. One of the things that's interesting is some of the power of Jinja 2 when it's being called from Ansible. And so they have this concept called text filters. And these are extremely powerful. So you see there's that item.ipv4. So that's a variable. And then there's a pipe. And just like you would on a Unix shell, where you can pipe and continue to have things go standard in to standard out, this is very similar, where you can pipe it to a function that then returns back a string. So this is pretty neat stuff that you can do because, again, people have utilized Ansible within a networking context, and typically this was a compute tool, but this was something very easy to add on. In fact, when we first started using Ansible, it wasn't really geared for networking, and we actually wrote some of our own custom filters to be able to support IP calculation. And now these are just built in. So it's really interesting to see how quickly and powerful you can build these templates based on technology that's already out there.
Okay, so we're going to go ahead and start with kind of building that framework. So we're going to do just build the inventory. So we're going to make the directory, make the host file, but we're not going to edit the host file. And then we'll dig into making the roles before we do any of the templating. So this is definitely a section that you probably want to follow along with. So let's go here. Talked about that already. Okay, yeah, so inventory and roles. Okay, so just want to make the directory, and you can call inventory whatever you would like, but I call it inventory for simplicity. And then inside of inventory, I'm going to make a file called hosts. It doesn't need any extension or anything. So now if I look at this, there's the reference, which we'll use those reference files later. And then we just created that inventory and hosts, and then there's the README. Okay, so the next step that we're going to do is we're going to go ahead and make the directory for the roles. And we could make all the directories at once, but I'm just going to take this slowly so that everyone can keep up with it. So we'll make the directory roles. This does matter how it's named, so we do need to call it that. I'm going to change into the roles directory, make directory, and we're going to work on some router configs today, so I'm just going to make that directory. You can see there's just that inside of there. And inside of the router, I'm going to make a tasks directory, a vars directory, and a templates directory. So now you can see what that looks like in terms of the directory structure.
We do see a few people typing along, so we're going to have brief pauses here for people to catch up that are actually treating this as a tutorial versus as a coffee break, so they can catch up. Can we get a raise of hands? How many people are actually following along and typing to demonstrate this? Okay, yeah, so more than 2 or 3. That's great. Appreciate that. So we're trying to make this as kind of a slow build-up. I think one of the things that's interesting here is that when you come from a system side, all this knowledge is kind of assumed. And when you're coming from a networking side, this is kind of a whole new world, this idea of templates and YAML and some sort of structure. And so we're trying to make these kind of in the bite-sized pieces that, again, by the end of the tutorial, you can take some knowledge home and start applying that.
Okay, so the next thing that we want to do is we want to go ahead and create those main.yaml files inside of tasks and vars. So we'll do tasks first.
Again, this is a standard Ansibleism, if you will. So when you use a role, as Broadband mentioned earlier, when it scopes the role for getting variables and the list of tasks, if you name it main.yaml, it automatically knows I can just call that role the role name, and it will assume some default locations.
Okay, so now we're going to go ahead and move up a couple of directories to the top of the workspace area. And if you look at the files that are there, we have that reference directory. Change into the reference directory, see what's there. So we have a couple of files there that are called config, different numbers, DHCP, stuff like that. And then there's an IP address file and there's a variables file. Let's go ahead and take a look at this variables file. So I included this variables file here because we wanted to just go ahead and assume that you were going to have, some variable information. This is just very, very basic, but we at least have, these IP addresses for these 3 different sites. We know we want a host name there, but we haven't necessarily picked one yet. And we're going to assume that we're configuring 3 different routers, and we want to create 3 entirely separate configs in this case. So I'm going to copy this information. You can just copy the file over to the variables directory if you want, or copy and paste, whatever works. So this goes into the vars. I'll move into there. And we want this information in that main.yaml file. So there we go. I'm going to give everyone a second here. Is everyone caught up to this point about? No, not yet. This is just our raw data. We're going to. Sorry, the question was: is this what main YAML looks like? The main.yaml file looks like. You should have this information in there, but we're going to reformat all of this information next.
Yeah. So the reference directory is just some reference data. It's not structured in a particular file format. So we're going to restructure this to be in a YAML file format.
Yeah, the idea is you'd have these IP addresses or this other information somewhere else, maybe a spreadsheet, maybe a wiki, maybe you have an IPAM or a database or something like that. Okay, so what we're going to do now is we're going to go ahead and convert this to the YAML variable file that we need to. So you want to do 3 dashes at the top here, and then a line break, 2 spaces to indent, a dash, one of these curly brackets, and a space. So personally, I like naming my hosts after different airports because that's what I do at work. So we're just going to go ahead and do that today for fun. So I'm going to call this router.jfk, and then you need a comma. And then you can bring the IPv4 section up to that next line there. And the important thing here is that you have the variable name, so in this case it's IPv4, and then you have that colon to specify this is the data for that particular variable. So then we have the IP address there. Do the same with the IPv6. And then you want a space at the end, and then a closing curly brace.
And there's obviously a bunch of different ways you can structure your data. We're just making this a very flat, simple list, but you may have what you consider a multi-dimensional array or dictionaries and including other dictionaries. There's all kinds of ways that you could structure this data. We're just trying to make it very simple and consumable for this morning, but there's lots of different ways you could structure the data.
So something that you don't always need to do, but sometimes you want to do, is you need to escape some of the characters. This router.jfk, it's probably okay, but it doesn't hurt to still escape it to make sure there aren't any problems with the data getting passed in or the YAML being misread. We're going to do the same thing with this IPv4. And it's actually really, really critical to do this with IPv6 because you can see these colons throughout the IPv6 address. What YAML will do if you don't escape these is go, oh, hey, wait a second, there's a lot more data here than you're saying there is. I'm having a problem like processing this. This isn't working.
Yeah, so the thing to note there is that YAML can basically express if this is a string or an integer and that sort of thing. And we're trying to make this, again, fairly simple and consumable. When we pass these on to the Jinja 2 template, they'll just be seen as a string. But when we pipe it to that text filter, which we'll go through momentarily here, the text filter will actually test, is that string a valid v4 or v6 address, whether it's a network or broadcast, it doesn't matter. And then it can actually do manipulations based upon that. If we were to put a value that was an integer like 10, you could actually pass that value and say, okay, +1 and make it 11. So the encoding can be important depending on how you're going to render that variable data in the end.
So I'm just continuing with these other 3 variable sets, so everyone should follow along with that. And you can give it any host name that you would like.
Now, one of the things you'll note here for these variables, these are network addresses, and we'll show why we specify these as network addresses.
We'll just give everyone a minute or two to make sure they're caught up.
Can we ask questions?
Yeah, sure.
Sure. So, sorry. I'm Chris Morrow. I work for Google, but this isn't a Google question, it's just a question for you. So,
I can barely hear you, so a little bit louder.
I'll speak louder. Is that better?
That's better,
Great.
thank you.
I'm Chris, I work for Google, but this isn't a Google question, it's for you. You did a bunch of spaces, some crap here, like how much of this is because you like style and how much is because else it won't work? Like, is this Python where spaces matter, or like space dash space, curly bracket space, hostname space, double quotes, single quotes?
Yeah, I think that's a good question. For YAML files, there is a standard, whether it's valid or not. You can run it through a lint process. A lot of YAML is dictated by how you want to lay it out. So essentially, you've got to have the three dashes to indicate it's a YAML file. And then you can have dictionaries, lists, that sort of thing. And how you structure those, as long as it's valid by the Python library, the PyYAML library that parses it, you're good to go.
Okay, so I didn't hear that this was a dict, so that makes it a little simpler to understand.
Correct.
But, and it's in the spacing.
Well, there's a list, but yeah.
Okay, fine, list, great. The spacing off the side, like the fact that it's one big long crazy line, like.
That's not required at all, yeah.
Yeah,
okay.
it's, in my day job, I got started doing it in this format, and then I've completely reformatted it, but there is some weird formatting stuff, especially with passing in variables into the templates. And we wanted to try and make this as simple as possible, so this was just the simplest way to go forward. It varies, though, depending on the format. So in this case, yeah, you probably wouldn't need those spaces, but there's a reason for that that we'll dive into later.
Okay, thanks.
Thank you.
Yep.
The triple dash at the beginning, was I just not paying attention when you said what that was?
Repeat the question.
So the question was the triple dash at the beginning. What is that? I didn't specify what that was. I just said go ahead and do that. But it basically it's the beginning of the YAML file in that case. So you want to do that, and it helps with like the formatting and everything. It does require that.
Yeah, so in the YAML file, that's just an indicator, I'm a YAML file. And so when a library parses it, it will start looking through those dictionaries and whatnot. If it doesn't see the three dashes, then it assumes it's not a YAML file.
Okay, so let's go ahead and move on here. So we're going to save this file. Exit out of there. Let's go ahead and flip back here. Okay, so the next step we're going to tackle here is we're going to look at the templates. As we mentioned, you can template just about anything you want. The formatting with what you output there is completely arbitrary. You control that. So you just have to have your template formatted in the fashion that you want. If you need some spaces, add those. If you need some like curly brackets, add those. It's really cool. And there's also a lot of really advanced features you can do that are awesome, including like if, when, and for statements and loops. And then the variable manipulation via filters, which is what we're going to be tackling in a little bit.
Sure.
Okay, so we want to go back up to that reference directory. Because inside there we have those configs. We're only going to use config1 for right now, but let's just go ahead and copy all of those config files into the templates directory. So the way that that's going to look is we're going to do
And again, these are just some reference configuration snippets. It's not a complete configuration.
So when you have those moved over, you want to look at the config1, because that's just what we're going to focus on for right now. So in here you can see I've already kind of replaced whatever data you might have had in there with the all uppercase words. So we've got name, description, IP address, netmask, IPv6, and then the gateway at the bottom. We would assume that you would have a config already, potentially, that you'd have all this data in, maybe from like a rancid backup or something like that, and you would then want to replace this information. So all of these items here that are in all uppercase, we're going to be replacing with variables. So we don't have all these items in our variables at the moment, so we have to fix that. So what we're really missing, we have the IP addresses, and for getting the netmask and the gateway and the IP address and IPv6 and everything, we don't need to worry about that right now. We're going to use the filters later. but we do need to add the description, and we've already added the name. So let's go ahead and add the description to our variables.
And again, that's just reference data, so we'll convert that into a Jinja2 template, just as we converted the reference data into a YAML variable file. Should make the data slightly different.
You know what? I'm actually going to fix something here because I don't remember if this causes problems or not. So you see this int underscore description? Is it fine? Okay. So you have to be careful sometimes because different formatting can cause issues in the variable names. So in certain places, an underscore will work, but in others it won't. In certain places, a dash will work, but then in others it won't. Matt just informed me that actually the underscore should be fine in this case, so we'll leave that.
Yeah, certain control characters in the YAML files, like if you had like an and signed as the key to a value, that could cause problems. So these are kind of standard limitations of the language that are they get interpreted incorrectly.
Yep.
If you could use the microphone, because there's a bunch of them around. So, sorry. We have remote participants that want to hear your voice more than ours.
Just that space after the IPv6 in the quote, is that space needed before the curly brace?
It's probably not needed,
No.
but I just do it as standard practice. It looks cleaner and it's more readable that way.
When you save out, can you dump out history for me? I have a little cleanup to do.
Yeah, sure. Yeah. Okay, so I'm going to go ahead and write this out. And here I'll show the history of things that I've done real quick. There's a lot of moving around. The other thing is that for anyone who is a little bit behind, some of the reference materials might also help. The big thing is really the structure. So I'm going to jump up here real quick.
Yeah, so we focused on creating a new role. So if you were to check out the data from the Git repository and that workspace directory, all you have is essentially reference data and a README. So we've created this roles directory, we've created a router role, and in that router role we have a set of tasks that we need to define. We're going to work on some templates, and we've already converted that reference data into YAML structured variables. So the next step is we'll work on taking config1 and making that into a J2 or a Jinja2 template.
So now we want to go back to the templates. I'm going to go back to editing that config1 there. And now we want to replace all of these uppercase words with the actual items. So in this case, we're going to do 2 curly braces and then we'll do item dot and then whatever the variable name is. So in this case, we have host name there. This is config1. That's the file that we're working in right now.
We're going to rename it to a Jinja2 file, so we're just taking it as a reference.
And for the description, we'll want to do that item dot int underscore description. For the IP addresses for right now, we're just going to pass in the IPv4 because we're going to have to apply some filters to those. Same thing for IPv6. Same thing for the gateway. Just going to give everyone one quick minute here because we're starting to get a little short on time. Yeah?
Yeah, that's on purpose. So what we'll do is that in this, the question was that in this example here, we have the item at IPv4 listed twice. Originally there we had the IP address and the net mask. And so what we're going to show is when we run Ansible, it's just going to replace that variable with the string that's set in the variables file. And in the next example, what we'll do is we'll actually put a text filter against that variable. So we'll make the first one, or sorry, the second one that you see item in IPv4, we'll pipe that to a filter that will show us the net mask. So we're just trying to show the steps because if we do it all in one shot, this is not approachable.
We might have to speed it up a little bit.
Yeah, we gotta.
Okay, so I'm going to go ahead and save this, and hopefully folks are kind of caught up here. Otherwise, I'm also happy to talk to people afterwards and explain some more things. And I'll also, all these finished files, I'll check them into the Git repo, so everyone will have them available, and you can look at them for reference. Save that. So we want to go ahead and go up a directory, because now we need to edit the tasks.
Config1 needs to be renamed to like config.j2.
Okay, so the tasks is also a YAML file, so you want those 3 dashes at the top. And then do you want to explain this stuff as I type
Yeah.
it?
So again, we've created a role called router. We've taken some reference variables and converted them into a YAML variable structure. We've taken a reference config and converted it into a Jinja2 compatible template. We're going to rename that to something like router template.j2 in a second here. And now we're doing kind of the third step, which is the actual list of tasks that we want to perform against that variable data. And so with this, we've got things like specifying, let's create an output directory. We want to make sure that exists. We're going to loop through a list of all of the variables that have been sourced and render the templates. So what Brahman is writing here is the first task, which is creating this output directory. So it's going to create that based upon variable data that's fed into it. And then we've got rendering out those templates. So one of the things that's interesting here is that Ansible is really into exposing variables pretty much anywhere in the entire stack. So whether that's in a template or in a play or variables referencing other variables, they're pretty much scoped globally which can be very interesting. And so that's one of the nice things about defining variables within a role is that they pretty much stay within that role.
So we've also done a couple of things here that we're going to have to go back and make a couple of changes to our variables. So this first task, we're verifying that the compiled directory exists, similar to that hello world example. And we just want to iterate through here that, we're just going to create this basic directory, which is the with items, in the configs directory. The cool thing here is then you could also add other things, like you can do complex. So then this would create multiple directories that you could then dump files into later.
So a lot of the Ansible modules, like file and template and whatnot, they can take an array or a dictionary of items. And so we could have just made the verify compile directory exist. We could have just said, okay, here's an absolute directory name, make sure that exists. But this is a little more fruitful if we wanted to have like a basic router config versus the complex router config. This kind of sets us up for that.
And so then we generate these basic config files. We're using a template. Actually, I need to fix this real quick because, again, as I mentioned earlier, roles know to look inside of the template. There we go. To look inside of the templates directory inside of that role. So we're actually just going to go ahead and remove that. So it should just be source equals config1.j2. And we didn't rename that config1.j2 yet, so we need to go back and do that. But we also need to make sure that this with items, the basic sites, that we update the variable file to include that. Because right now we just have the variable sets in there, and we don't have, like them broken out in any capacity. Okay, so we're going to save that, and I'm going to go ahead and edit the variables here. Call that basic sites. So now all these fall under basic sites. Cool thing about this is then we could have something down here that said complex sites, and then put those variables under there. So it's nice because then you can actually move different variable blocks between those different sections.
Again, we're just scratching the surface here. There's a lot of different ways you could structure your variables that you're feeding in.
And we're going to go ahead and speed things up a little bit because we're really running short on time, unfortunately.
We got to rename.
Yes, we need to rename. So what we're going to do here is we're going to move into the templates, and we're going to rename that config1.
This is the file that we took from the reference directory that was just kind of a example of host name, capital M, A, M, E, how to, the kind of search and replace values, and now we've converted it into a Jinja 2 template.
So you can see right here it's now a .j2, which is what we referenced in the tasks. Okay, so now we can tackle the playbook. And apologies again for having to speed this up now. So we're going to go ahead and make that playbook. We're just going to call this playbook for right now. And the playbook is also a YAML file. You want to explain the stuff as on?
Yeah, so again, as we mentioned earlier, the playbook is kind of the heart of Ansible that can reference these roles, these variables, and these templates, and various other modules. You could put all that in a single playbook. You could have one file that has all this data. But the goal here is to structure this to be reusable for different components. And so we're just going to reference that we've made a router role, and then it's going to source that in the router role, it's going to source the play in a list of tasks that we've defined there.
Okay, so we're saving that. And let's see, here's the tree, so you can see everything here.
So we've created this, scroll down. We've created this role called router. It has a task to create a directory called output and to render templates based upon the variable data that's in the main.yaml, and it's going to use the config1.j2 as the template.
And up here, if you scroll up, there's all the reference files still, and then we've created this playbook.yaml here. And we have this inventory, and we still need to edit the host really quickly, and then we can actually run the playbook. So you can just call that local. And so this, it showed you that example before where you can have this name, whatever you want, and so you can group together different hosts. You can also reference the individual hosts that are listed under there. So I can reference local or localhost, and it'll get me either one.
So local is the group, localhost is the host.
Let's switch back to this. Oh, we need to do that.
Yeah, well, let's just run it first.
Yeah. Okay. Okay, so we're going to go ahead and just run this play, and we'll explain the playbook in a minute. Okay, so here you can see that this worked. So we verified these compiled directories existed, and we generated these basic configs.
Yeah, so what we're doing is Ansible-playbook, space-I for feeding an inventory, space inventory that sources that inventory directory, and then space playbook.yaml where we're specifying this playbook that we're running.
And actually here, I'm just going to go to this slide real quick so I can show this. So here's what we did, except we called ours I called mine playbook, but you could call it my playbook, you could call it whatever you wanted. But essentially there's the Ansible-playbook, that's the command. The -I is the flag to say I'm going to pass in an inventory.
Instead of that system-wide location, that etc. Ansible inventory location or Ansible host, we're specifying a locally scoped within our working directory.
Yeah. And then there's the directory inventory, which you could call it whatever you want, but we call it inventory for simplicity here. And then there's your playbook file, which in my case I called it playbook.yaml, but you could call it whatever you would like.
Okay, go back.
Okay.
So I'm going to ask you to run it one more time.
Just run it
One more time.
Okay.
And what you'll notice is that the output is all green instead of yellow because none of the resulting files that get compiled out have changed. So now let's look at what those files look like. So it's generated a configs directory, and it's taken that variable data to generate these text files, not only for the name of the file, but also for the data within the file. So here we've got the host name, we've got the IP address listed twice, which we're about to fix, the IPv6 address, which we're going to fix, and then the gateway, which we have to change some of the formatting there. So all we've done is taken structured strings from a variable and put it into a resulting file. Let's definitely do that. So now what we're going to work on is taking that template and calling a text filter. So this is a Jinja 2 functionality where you can take a variable and pipe it to a module. And Ansible includes a hook to a Python module called NetAdder, which was actually originally came from Google, I believe. And that module can do IP calculations. And so as you noted, our variable is a network address. It's not a usable address. So we're going to pipe to this text filter that's going to translate that. And this text filter is pretty powerful. So what we're going to do here is pipe it to the IP adder text filter module. And this is fully documented within Ansible. So if you search for Ansible filter IP addresses, you'll get the results for this. So as noted earlier from the gentleman that we have the network address listed twice. What we're going to do is pipe this so that one of the outputs is the first usable IP address, and then the second output is going to be the net mask. Similarly for IPv6, we can also do a similar output.
Yeah, the IPv6 one's slightly different than Okay, so you can see here that with the IP address for IPv4, for IPv6, and also for the gateway at the end, we're using the same set over and over there. There's actually a shortcut way where you can set that, which we were going to show if we had more time, but for right now we'll just do this. And as I mentioned, I'll upload all of these files too, so everyone has access, and I'm more than happy, both in person and then over email and everything, to help with this later. Okay, so we're going to try running that again now.
So again, the data has changed. The resulting files have changed. That's why we see the yellow. So let's go ahead and look and see what resulted out of that. Okay, so now we see things are a little bit different here. The first is a description. We piped that to a text filter called upper that just took that variable data and made it all uppercase. We used the IP address module to take that variable that was just a network address and to break it off into the first usable v4 address. And then because that network address was specified as a CIDR notation, we were able to infer what the net mask was. And so we put it in a file format that would be compatible with a Cisco iOS device or similar to that. You see the same thing for v6, first usable address there. And then you also see down for the gateway that we took that same IP address. Now, in a real world example, you wouldn't have the gateway and that device plumbed to itself, but it just gives you an example of what's possible with just very basic functionality. And when it comes to the hands-on effort here, we've probably spent maybe 20 minutes, and we've taken variable data and been able to generate a configuration file from one variable and generate very different iterations of it. And there's a lot of power that you can do with these text filters.
So we unfortunately don't really have time to show some of the advanced examples here. We at least broke down running this play. Hopefully you were able to follow along in time and you've got configs, which would be fantastic. If not, that's okay, because we'll publish this information. And if it didn't work, if you did follow along and something went wrong, there's a lot of different issues that can happen along the way. Common issues: missing packages, variables, formatting, weirdness, typos. Ansible can provide some clues to that. This is just part of the process. Here's some examples really quickly of some issues. There's undefined variables. There's the host name is undefined. There's syntax errors. These are very basic. They can be a little frustrating to debug your first time, but they're not insurmountable at all. We don't have time for this today, unfortunately, but maybe I'll post a video demo online or something. But there's a lot of cool stuff you can do. You can loop through multiple interfaces. You can add a lot of logic. So if a certain flag is set, then you can include a config snippet or you can exclude it. And you can also do even more IP address manipulation than just the small example that we showed today.
So some of the next steps is that when you have these templates being generated, that's great. You're going to generate on your local host, but you want to deploy them to your actual device. So there are a number of modules that vendors have written that plug into Ansible. Napalm, which was actually presented at the last NANOG by David and Elisa, it actually is a pretty neat module that can take that resulting config file and deploy it to a device of these various operating systems. So EOS, Junos, iOS XR, and the Fortinet operating system. And they actually provide some hooks where you can not only deploy that config, but you can roll it back. And in some cases, they're using an API. In other cases, they may have to result in some terrible screen scraping, but we certainly hope that's not the case. There are other vendors that have their own modules that plug in to Ansible. Again, this is because typically on these operating systems, that Python runtime is not available. That's not a problem in the case of Cumulus, but some of the other platforms, that's not necessarily there. And there's a lot more to Ansible than just that, and we hope to show more of this in a 201 tutorial.
We'll make sure we pick a 3-hour time slot in that case.
So I wanted to show kind of what that would look like really briefly. Again, it would be rendering that compiled configuration file and then deploying it to a device. So you see that installed config. Again, that would be one of those vendor-provided mechanisms to push that config out. And each vendor, again, is slightly different. Some of them, it's screen scraping to take a config and buffer it in. That's the worst case. Some of the best ones actually use native APIs to deploy that configuration. So a little bit of homework. I think one of the things that's interesting here is that having automation touch your production devices is pretty scary. So look at using something that's not public facing first. A monitoring system is a great way to do this. Monitoring systems typically are not public facing and they can be duplicated, so you can have a separate monitoring system and just disable the alerting. One of the things that's important to note here is to ratify what we call a source of truth. So you probably have some definitive data in your organization. And as Bronwyn mentioned, that could be in a database or an IPAM, or maybe it's in rancid backups, and you can pull it out of there and use that as your initial source of truth. The other thing is look at your NOS vendors. A lot of them will have VMs available, so you can actually test all of this on your laptop or your desktop without ever having to go into the lab and do a POC. A couple of resources that I think are important for folks to look at. All of these resources that are mentioned for the blogs, these are actual network engineers that have been consuming Ansible to use in network environments. These are not the traditional Ansible users that are using this compute environment. So they have a lot of great examples that you can consume. And these folks are a lot smarter than us because they've been hacking on this for quite some time.
And with the Ansible books, they're not geared towards networking at all. They're very much on the Ansible side of things. But it's good to get more familiar with it, to get more comfortable with it, because then you can figure out how to make it work in your particular networking situation. So there's more resources increasing. And if you get into this, then maybe you can also become one of those resources and really contribute to doing more of the networking side of things with Ansible.
So let's talk a little bit about the future here. One of the things that I wanted to close on is, again, some data. This was a random sampling of talking to a few NSPs and ISPs that participate within NANOG. And one of the things that was very interesting is, in the case of all three of these, a domestic MSO, an ISP around the world, and an ISP also focused around the world, but essentially a tier 2, they all use some form of automation. They've all solved this source of truth problem. Now, they're not necessarily using Ansible, and not necessarily even using open source, but this is a very powerful tool that they use day to day. So it's not something that's not approachable that just the big guys are going to have, but everyone can start adopting this.
And so the most important thing is to remember that this isn't an investment. We did have to rush through things today, and I apologize for that. But it takes time, and start small and just be iterative. Like tackle a small problem. And it can end up being a big win for you and your team. Doing the configuration generation for me turned something that I was spending 30 minutes per site on to something I spend 2 minutes per site on. And now it lets me look into trying to figure out these bigger networking automation problems now, which is really great. And big thing, don't get discouraged. Like, it can be a little frustrating at times, and maybe you don't want to use Ansible, and it's totally fine. But find like a tool that works for you and your team and your workflow, and just tackle those small problems, and they'll add up and make a big difference.
So we'd love to do more of this just within the Gen 2 functionality. There's a lot of advanced templating skills that you can have, where you can have a base config that includes other configuration files. So you can imagine a base may be your license keys or a basic config like NTP and usernames, but then you have separate configs for your routing protocols. There's a lot of options there. Looking at existing ways to port into Ansible. So one of them is that if you have rancid backups, you can take that data and then generate a YAML file. Or Ansible even has something called a dynamic inventory. So instead of having a flat file, as long as a script in any language dumps out a YAML compatible file format, it can input that data. So if you have an IPAM, info block, 6connect, that sort of thing, you could have that data stored there, dump it out as a YAML file, and then it would be compatible to use within Ansible. Again, interacting with network devices, we mentioned on the slides there, they have links for all the network vendors that provide Ansible support. And then we'd love to do some more Ansible specific things around facts. So for example, if this device has X software version running on it, we retrieve that fact data back, and then we can make a determination, oh, we need to upgrade that device, or not to roll this template because it's an older version.
So we'd love to hear from you. Fill out the NANOG survey, please. And definitely come talk to us. We're here all week. We're happy to answer questions. Any tips or pointers we can give to you. You can email or tweet us. And we'll also make sure that there's a lot of updates done to that Git repo. So keep the link to that, because we'll provide a lot more information there so you can keep building on this. Thank you.
Yeah, I think we're out of time for questions unless they're really short. Okay, so we've got a little bit of time if there's any questions. And if not, you guys have all become masters of Ansible.
You're on the path.
Great.
Okay, folks, we're moving into break right now. After break, which ends at 11:30, there will be another round of tutorials and tracks. We've got Crassy doing the security track over in Joliet, and then we're going to have the Wi-Fi tutorial right here in the general session room. That's going to come up at 11:30. That will run until 1. At 1 o'clock, we'll have lunch. If you look on your agenda, it says lunch is from 1 to 2, but you'll notice that the session doesn't start again until 2:30. So you get that extra half hour to kind of do things like manage your acid reflux or have hallway conversations or take your time getting back, do some things in your room, whatever else you need to do, make phone calls and that kind of stuff. So we give you that extra half hour now. And then we'll start the general session at 2:30. So tracks and tutorials resuming at 11:30 and then general session at 2:30. Thanks.